Hi, welcome to the demonstration corner. My name's Kelsey. I'm an application scientist here at Thermtest. So today we're going to be going over the MP-V, which is the measurement platform Versatile. So this is our mid-range measurement platform for testing solids, pastes, and powders with a combination of a few different methods. So these would be transient hot wire, transient line source, and transient plane source. So today we're going to be talking about the transient plane source for testing slab materials. So the transient plane source with the MP-V can be used to test thin sheet-like materials up to 1700 watts per meter Kelvin. So today we're going to be testing titanium slab. So we just have our slab samples here. And if we just come in a little bit closer, I'll show you the different ways we can set that up. So here we have our transient plane source sample holder. So this can be used to make measurements at room temperature, and it can also be used in an external oven up to 300 degrees Celsius. And today we're going to be talking about our Ecotherm dry bath. So this connects directly with the MP-V for ease of use with the software to test samples from 0 degrees Celsius up to 100 degrees Celsius. So to test a slab sample with the transient plane source method in a symmetric configuration, we're going to want to place two pieces of sample on either side of the transient plane source sensor with a material of known thermal properties on either side, and this just enforces the boundary condition so that there's no heat transfer beyond the sample. So we're just going to set that up in our dry bath. So there's quick connections with the dry bath for ease of use. So we're just going to place the bottom half of our insulation material first, and then one piece of our titanium slab on top of that. And then we've already attached our transient plane source sensor, so we're using the 3.2 millimeter radius to accommodate for the size of our sample. So that's already connected with good amount of electrical contact between the sensor and the sensor stand. We're then going to take another piece of our titanium slab and place that on top with another piece of insulation material for that symmetric configuration. So we also just have a protective disc on top there because we're going to clamp the samples together. We just want to protect our top insulation material. So then we're just going to secure this in place with our heating cell. So we're just going to place that on top and secure it in place with a screwdriver. And then we're just going to tighten the top screw to clamp the two samples together, just to ensure there's good contact between the samples and the sensor. And we're just going to place the lid on top of the sample setup, and now we're ready to move to the software and set up our measurements. Okay. So once we open our software for the first time, we're going to see that it automatically detects what's connected. So here we see our MP-V as well as our dry bath and our transient plane source connection. So then we can go on and begin setting up our schedule. So in the general page, we're going to want to enter some general information, the user ID, the location we're going to want to save our results to, and then we're going to want to select our method. So we're going to be testing with the transient plane source 3D method, and we're going to select the slab modifier since we're testing our titanium slab samples. So if we just go next, this is just going to show what devices are connected. So since we want to set up a measurement with our dry bath with temperature, we're going to select the dry bath, and that's just going to appear on the screen. We'll go next, and here's where we're going to want to enter all the information about our sample. So we're going to enter the sample name, the backing material we're using. So for this, we're using calcium silicate, which is a high temperature insulation material. We're going to want to enter the sample height. So this is 0.125 millimeters, and the radius, 5. Then we're just going to select the sensor stand that's connected and the sensor model. So if you don't know what sensor model to pick, you can select this light bulb, and it's going to recommend the appropriate sensor to use for that sample. Now we're just going to want to check the resistance of that sensor to make sure that it's connected well. Okay, perfect. And so the temperature is recorded automatically. Here we can select to run ITPS, which is the Intelligent Transient Plane Source function. So this is just used to automatically suggest the appropriate parameters for each of your sample if you're unsure. So you can just select thermal conductivity of range of your sample. We're going to be selecting medium for our titanium, and then you can select ITPS. So this is just going to run a continuous transient to determine the appropriate parameters. We're not going to run it for this demonstration. We have already determined our parameters. So we're just going to select our test time. So we're going to set up a 2-second test with 60 milliwatts. And if you'd like to verify these parameters, you can run a quick transient. So with the quick transient, you can just check the temperature rise and make sure that your sample is seated correctly and the results are what you're expected. So once that's all set up and ready to go, you can select next. And here's where you can set up your schedule. So if we want to set up a schedule with automatic temperature points, we can select this button to add a range of items. So here we can select the temperature range, so we could go from 0 degrees to 100 degrees every 10 degrees Celsius. The power, we already decided we're going to run 60 milliwatts and 2 seconds. And if we just select add schedule, this is automatically going to generate our entire schedule. And then we can just hit start and it will automatically begin. So we already ran some measurements with the titanium slab, so we're just going to do some review of data. So here we just have it opened up here. These are the results we ran. Our residuals show a random scatter, and our results show that the thermal conductivity of this specific sample is 25 watts per meter Kelvin. So here you can just do more analysis of your sample if you'd like, as well as export it to Excel. And that's about everything for running a transient plane source slab experiment with the MP-V and the Ecotherm dry bath. Please reach out to us